Hello, my name is Doug Wood. In this talk, we're going to learn how quality tools can help us measure cost of quality in a project management environment. We're going to talk about how to understand what the cost of mistakes are, the fact that it is a key performance indicator for your leadership. We're also going to talk about how cost of quality, which was originally a manufacturing metric, is adaptable to project work. And we're going to talk about some spreadsheet tools that you can use to measure quality costs. To begin with, what exactly is cost of quality? Well, this idea has been around for many decades. Some people have heard the phrase cost of poor quality, but cost of poor quality is only part of cost of quality. In total, cost of quality is the cost of your mistakes, tracking what you're doing, and what you invest to make process or program improvements. Money is the language of management. It's how executive decisions are made and judged. To begin with, what does your company want to improve? Is it share price or market value or revenue? I know you might be tempted to say all of the above, but typically these things come in some kind of an order. One or more of them is more important than others. To identify that, you need to look at your strategy and talk to your leadership. What is it that you're trying to improve? This will guide your implementation of a cost of quality measurement system. Let's take a look at an example profit and loss report. Here you can see there's income and expenses listed, and we've simplified this to make the relationships clearer. You start off with a certain amount of total net sales, and then there's a cost of sales. You got to spend money to get those sales. There's a gross profit here listed at $88. Then you've got a series of expenses. There's fixed expenses and there's variable expenses. The controllable expenses or variable ones are generally it's generally salaries and wages that are the largest piece of this. One of the difficulties of looking at a profit and loss statement, while everything's in there, you cannot see cause and effect. Where are the drivers of issues? What could be driving up wages? What could be driving up the costs of legal or accounting? You really can't see that here. So cost of quality as a measurement system will help you make cause and effect visible. To begin with, we need to understand what are the categories that fall into cost of quality. There's investments to improve processes. In older textbooks, they call this prevention, but investments is a language that resounds in today's world. There's also going to be monitoring expenses, and they used to call this appraisal expense, but this is money you spend to tell what's going on. Then there's the cost of waste. This used to be called internal failure costs, but we all know what waste is. And finally, there's what used to be called external failure cost, but this is what we're terming downstream consequences. Now, none of these four categories includes the cost of good business or the expense of successful actions. So what we're really talking about is a portion of your total expenses broken into these categories. Does cost of quality work in project management? Of course it does. But the categories look different when you draw the numbers together, and the approach needs to be modified. For one thing, a factory is a steady state. You're making a lot of items and they're pumping them out, and so you can measure it over time, and it's going to be the same 1 week to the next, or generally the same. But with projects, there's a beginning, middle, and end. And so the cost of quality looks different at the beginning of a project than it does at the end. You also need to have the proper data collection. Oftentimes the data collection is not at a granular enough level to really see what's going on. What you're going to do from this data is you're going to develop curve families. We'll talk more about that later after we introduce a couple more concepts. This idea is currently being used by at least one large Kansas City engineering firm. They've implemented this and they use it as a matter of competitive advantage. Let's talk about what we mean by curve families. So here might be data collected over 13 weeks for a normal project. This is sort of a run-of-the-mill project that you do a lot of. And you can see on here that we've collected 3 different categories of data. We're using the words prevention, appraisal, and failure on this chart, which is the older language. But you can tell that, yeah, your prevention is generally early in the project. And as time goes on, that reduces. The appraisal is more or less constant, although it kind of ramps up and then drops down again towards the end of the project when less appraisal is necessary. The failure cost, however, just tends to rise, and this is typically because as you get towards the end of a project, when something breaks, you have to go back and do a number of things over again. And so the costs continue to rise. So you could take a series of projects that are normal and you could create a family of standard curves. Let's take a look at a different project though. Now this is a project that is new to you, something that you've not done before. Notice how the prevention cost is much higher in the beginning because it's new to you. You need to do a certain amount of retraining or study or gathering information to do a good job. Also the failure cost still rises, but it might tend to rise earlier in the project rather than waiting until later. Here we're dealing with a very complex project. As you can see, there's some appraisal. The dollar amount at the left on the project might be larger than any other ones. One of the things that you'll find when you collect data on a number of projects is that there's going to be a varying dollar cost up and down, and there's going to be a varying number of weeks left to right. So multiple projects are going to have to be normalized to bring them back to the same scale, left and right and up and down. Then you can do curve fitting analysis to determine what is a normal situation for these various types of projects. This normal curve gives you a standard to shoot for when you run new projects. Well, a complex project, for example, though, here is going to have many moving parts and many subteams. And so you may have a failure that arises early, drops off, and then rises swiftly at the end. This is possible with a complex project. Again, your projects are going to result in distinct curves that fit your needs. In order to make curves like this, you certainly need to collect data, and you need to have a solid collection of data based on timing. Oftentimes we see there are individual time allocation records to various projects' work. Most people who've been in a project environment have filled out some kind of a timesheet that assigns their daily tasks to different projects because they're working on more than one project at a time. That's typical. You need to have categories in this time recording, which is suitable for quality costs, the 4 categories we already talked about. The data needs to be reasonably accurate, and it needs to be sorted by what is the characteristic of the project. Now notice I'm saying project characteristics. I'm not giving you those categories. Ideally, after you've collected data on multiple projects, you're going to begin to see families of curves that belong together. Then you're going to need to know what are the characteristics of projects that fall into this family. So there's a fair amount of work that has to be done in order to develop a sound basis for this. Let's take a look at a time sheet and what that might look like. Here we have 2 different engineers, and they've been working on different projects and different stages in those projects. Based on what task they're doing, how are they spending their time, you can develop a report like this. Now notice the project activities are coded in some fashion. And here we're only looking at the project activities that have to do with prevention, appraisal, waste, and downstream consequences. And so by categorizing these different things in these categories, for example, the M might be monitoring and the I might be an investment. So you could then categorize their time. Now, 100% of their time is not listed here. We're only listing a portion. But notice that one of them has 25% of their time spent on cost of quality. The other one spends 64% of their time on it. By looking at their monthly pay rate, you can actually determine the cost of what each of these different categories are. You need to collect enough data on enough multiple projects so that you can ascertain what families these projects fall into. So in this case, this is a systematic approach to cost of quality, which you're going to apply across all of your projects. As more projects are sorted out, time and costs need to be normalized, as I said before, longer and shorter time frames, higher and lower expense. Then you can begin to do curve fitting and determine what standard curves would look like for these various types of projects. You don't have to measure everything. Some costs are too small or they're unimportant. Some of them are really difficult to measure. And some costs are so spread out that control is very unlikely. We're going to call these hidden costs. It's an aspect of cost accounting that everything needs to be measured and put into the overhead or the operation costs of the business. Quality cost is a piecework. It is taking pieces of cost. But how else can you see cause and effect? When we talk about hidden costs, there's going to be those that are commonly measured and easy to see. You can see them above the waterline. Again, this is the iceberg that you probably have heard about, where 10% is visible and 90% is below the waterline. Most of your costs are going to be hidden and scattered and almost unmeasurable. But here's the trick. By measuring the ones that you can see and working to reduce those, you will reduce the ones that you cannot see because they're all driven by the same causes. Let's talk a little bit about what tools you might be able to use. Number one, a flowchart. A flowchart is crucial because otherwise, how do you see unique, or how do you see whether situations are similar and which ones are unique? I mentioned curve fitting, and curvilinear regression analysis is typically what's used on project groups. Again, we're not going to go into that detail here. That is a statistical tool, and there's many statistical packages that enable that, and you certainly need to have a certain amount of background in statistics to apply that well. Confidence intervals on these curve regressions will show how reliable they might be. Looking at the spread from project to project of the curve regression analysis, the confidence intervals place high upper and lower bounds on these lines that you're going to draw. The more projects you have and the more data you have, the tighter the interval will be, and the more accurate, the more reliable your prediction will be. In some cases, you may need to do some kind of hypothesis testing to say, so how well does this curve fit a given project or a given project category? Now there's another tool we're going to talk about here, a way to get started. And you can use a spreadsheet to do a single project cost of quality. Let's take a look at that. This is an example of a spreadsheet that I developed working with a client. They were trying to measure the cost of quality on a lean project that they had put into place, or perhaps the word agile would be better here. The point is that you've got the 4 categories listed there, and you go through and talk to the project management and the project team, and you determine, so what are the different activities that we spent before we made a change to our methodology and after we made a change to our methodology. And so you can see on here there was some investments that were made to drive the change to the project methodology. Certain amount of training, doing some research. And so you count how often it happens and you put the man hours in here. This is just a simple spreadsheet calculation. We have a a holding value for labor per hour. Yours may be higher or lower than that. And then we have some material costs. And the point here is that these three different kinds of investments are coded as an I in that right-hand column. Now we'll see what that does in a moment. That I says these are investments. So for this project, they put $8,000, $8,700 into investments. Now monitoring is a different category. That's where time, it's something you spend to measure things. And so we've got three different categories here. Frequency is different, the occurrences are different, and the labor hour is the same. So we look across here. You'll notice the first two are listed as B. Those were techniques that we're using before we made a change to our project methodology. The last row, altered measures, is what we did after the project change was done. And you can see the man hours per occurrence was significantly lower, and therefore the expenditure for monitoring after the change was made was significantly less than the expenditure for monitoring before, B and A over there on the right. So the next one was waste, and it works just the same as monitoring. Okay. In some cases, you might actually have a % reduction on the B's. In other words, reworking documentation might be, affected dramatically in that second row that says reworking documentation. And after, it's going to be significantly less. So you might have a % reduction there. And again, downstream consequences, you may not be able to measure the after effects of these things. So then let's go on and take a look at what the before, the investment and the before and the after does for us. But also, what are the four categories? So you can see here, there is a bar chart that identifies how much was spent on investments, monitoring, waste, and downstream consequences based on that data. Because you've coded some things as investment and some things as before and some things as after, you can total up your cost of quality before, after, subtract the difference, there's your savings, and divide that by the investment, and you can actually determine a payback on your investment. So those are some of the things that this sort of analysis can help you with. In summary, we've talked about how cost of quality can fit in project management, and I think you can see that there are tools and techniques that can be used to measure cost of quality in a project world. We've also discussed how project cost curves can allow prediction. A project manager could take a standard curve for a project they're starting on, and they can look at, have I spent enough money on prevention so far? Where should my monitoring cost be? This can help a project manager guide a project during as the project continues. We've shown you a little bit how you can collect data to measure quality costs. There's multiple techniques, but we've really focused on the time and attendance category. And remember, you do not need to measure all the quality costs. It's not necessary to measure all of them to understand what direction you're going to go in. We recommend that you start small with a project with something like this, and you gradually grow into it. And we've shown you a spreadsheet that can measure an individual project's cost of quality. I certainly hope that you picked up a few tips and tricks from this talk. It's a relatively short discussion, and we didn't get into a lot of detail. The references might help you figure some things out. If you have more questions, you may contact me. dcwoodconsulting.com. My LinkedIn address is there, and so is my email. I'm open to any questions that you might have on this talk. And again, we wish you well.